Today we're going to go over some of the features on our bumper spring. We're going to have a nice little conversation about some of the different design aspects and engineering that went into each one. We're also going to follow up with a mini video series on each component, going into more depth behind some of that engineering that went into them. To start, I guess we can talk about the fishneck. Something that we have come to believe is that you're overpaying for your titanium fishnecks. That's kind of our standard and how we view it. There's a few reasons behind that. We build ours out of 4140.
Right. So we start with, rather than just 4140, we actually use a preheat stress relief. So it's CR 4142. That gets us to about a 32 Rockwell C to start with. And then taking it through a two-stage nitriding process, we're able to pull all of the nitrogen out to the surface of the steel, which gets you above a 50 Rockwell C.
Yeah, and this is the same process. This isn't our own nitriding process. This is what's used in the firearm industry. This is what a lot of manufacturers, gun manufacturers, use on their barrels before they send them out for service. So it's widely used. It's not our own technology or anything. And like Cole said, it gets you up above that 50 Rockwell C. And for putting it into perspective compared to titanium, titanium is about 380 on the Brinell hardness. I know we're kind of hopping between the two scales, but 4140 pre-QPQ is 280. So obviously a gap in just the raw materials, but then once we do the QPQ process, it takes that outer 5,000ths layer of the 4140 to a 475 Brinell hardness. So it's actually outperforming just raw titanium pretty handily. And that's why a lot of people go for the titanium fishnecks, because they're harder, because they have issues with mushrooming and things like that.
It also is very corrosion resistant. So very cost effective too. So you get a great piece of steel that's corrosion resistant, outperforms titanium in its hardness, ductility, in a lot of ways. And then from a manufacturing standpoint, Cass can tell you a little bit about turning titanium. It's not a fun process.
It's very not a good time. No, it's not fun. It's completely different tooling.
I guess we can move
on to the spring.
To the spring.
So a lot of people kind of overlook, a lot of manufacturers kind of overlook the actual coil spring itself. That's something that we've noticed in the industry, is we're finding a lot of competitors' springs are out of what's called index. It's this range where an acceptable range where engineers have decided if it falls between these two numbers, then it's acceptable. It's going to have a longer surface life. It's going to perform better. And what we've seen is some of the competitors of springs that we've tested and stuff like that, it comes out to like a 3.2 and a 3.5. And you're within index if you're between a 4 and a 12.
4 and a 12, yeah.
So we fall right at a 4, our spring does. And what the biggest difference is, there's two. Our wire diameter is a little bit smaller, and then our number of coils is not as tightly wound. And so what this gives you is a further travel. So if you are pulling out your bumper springs and they're about a 1/2 inch or a 1/4 inch short, what's happening is your spring is going past its max allowable compression point. And we have a couple of things that we use to keep that from happening on our spring, but basically you get a lot more compression, a lot more springiness, which helps with the longevity of the spring overall.
So when your index is below a 4, you have a lot of tension wound in your spring. So like Cass is saying, when you get that compression, you're not able to extend back to full length, and that's why you're seeing that gap. It's all relative to the index.
And the other thing that happens, and this is typically where springs fail, is they will compress and they will stack out on top of itself, and that's when the spring shears. The material becomes brittle after it's down there for 6 months, 8 months, a year, however long you're running them for, and that's where you're going to see that spring start to shear. So that's where the disadvantage of having a shorter travel is. We do a 3-slot design, pretty big slots from what you can see there. This is to maximize the allowable flow. So very substantial. It's not going to crush under dry falls, hot arrivals and things like that.
One of the other features you know, your no-go is right
Mhm.
here. We've taken that same OD of the no-go along the body of the spring for, you know, a real big chunk.
Mhm.
Some springs that we've seen that have short no-goes, if that no-go gets worn or you have repetitive dry impacts, you can really push your spring through your X nipple or whatever nipple you're running and actually lose it, you know,
Yeah.
through your into the end of your tubing. One of the designs that we have that is unique to us is the brass no-go. Um, we had a lot of springs that were sticking, and when we would do a failure analysis on them, you know, the similar metallurgies just seemed that they would like they were locking together. So we went with a design of using the brass dissimilar metallurgies. We use 360 half hard brass, so it machines easy, but it's also a very strong material. It's not, you know.
Yeah, a lot of people see the brass and they get freaked out. They're
Yeah.
like, you're just gonna mush that in there. And
Yeah.
no, it can withstand a lot more pressure than you think.
360 half hard brass is, you know, a very strong material. Kind of the inspiration behind that was, you know, brass case on AR rounds versus steel case.
Yeah.
You know, you jam up a lot of rounds on your AR if you're shooting steel case, and then brass would just come out like butter.
Yeah.
So we ran the numbers on it and thought, you know what?
Why not try it out?
This.
Yeah,
And
it's a good idea.
a lot of times, slickline crews can get them out without setting off their oil jars. They can usually just spang them out, and they've probably sold more of these than we have because they love how much easier they are to remove.
Yeah.
It saves a lot of wear and tear on their equipment.
I think the last thing I want to talk about is probably this guy here. This is a stack out for our bolt. So kind of going back to that spring design a little bit. If you remember, we were talking about how if your springs are coming out a little bit shortened, means they're going past their max allowable compression point. So what we did was we take this insert essentially, and it sits right below the end of this slot right here. And then your mandrel will thread in and back it up right here on this back end. And what will happen is when that spring takes a hot arrival, a dry fall from your plunger, this bolt is going to be stopped by the insert before the spring can go past its max allowable compression point. So essentially, it's just a safeguard to back up your spring in case you are doing dry falls and it seems like you're tearing things up. This kind of helps the spring last longer and have more of a service life.
Yeah, it's a great design.
Yep.
Another feature that we have is our auto dump feature. We don't use a traditional ball like a lot of manufacturers. You know,
it's more of a lollipop or whatever, a dart.
Kind of a
dart, really.
We call them a dart, and these actually end up being more cost effective to machine rather than purchasing balls, which was why we went down this path. And then, you know, it gives us a few key features that we really like for being able to dump fluid,
but also suspend fluid, hold that fluid in very steep angled inclinations and stuff like that. We do utilize kind of that spherical shape, and I'll zoom in on this so you can kind of see what it looks like. But we use that mirror geometry in order to seal and kind of hold up during pretty steep angles.
You can get into some angles. You know, there are. Our product was not designed for deep deviation, so when you start getting past that 45, 60 degrees, Quicksilver's got a great design.
Q2 Quicksilver, the barbell design, that's a really good one. Yeah, we've seen that, and it seems to work really, really well with steep stuff. So, yeah, that's a good product to go chase after. But yeah, we'll be coming out with more videos on just each of these components a little bit more individually so that we can go into some of the homework and the engineering design that went into the back end, kind of show you the difference between some of our stuff, what other competitors are doing, maybe why we need to change what we're doing. You know, don't take our word for it. Go do your own research. Look up anything we're telling you. We encourage that. So be on the lookout for those videos coming up soon.